that out. Just doing a skim coat on this one to give me a true surface for me to chuck with. This is the input feed. There is no bearing. It's run on like a, looks like to me it's on a cast iron bearing. So from that one we will true that one up. The inside race is fine. It gives me a nice true reading, but on this side when I tried to chuck it up, combination of the paint and the rough exterior housing, it just was coming in about 18 thousandths worth of run out. So okay, not a perfect surface, but should be something for the chuck to grab a hold of. We have two bearings, or two bearings. We have two seals that we're going to install, and this is again for the sealed surface. Right here is the hole where we're going to punch that out and tap that to probably at 1/8 pipe thread, and then have a drip oiler into this one. The bolt hole pattern needs to be updated. If you remember from the previous video, where it was just cutting the ragged edge on the inside of the case. So my plan is to bolt it back into place with those weak holes, and then already have the radius drilled, and then from there we'll go ahead and line it up with the old holes, so that way the orientation of the input gear should be pretty good, because it had no problem with the bowl gear and the input gear. So I'll use that as the alignment tool, because there's nothing inside the housing to center it. So we'll line that up, and then we already have the holes on the radius punched. We'll transfer punch those into the housing, and then we'll drill and tap those in, and then these old holes we'll probably fill them up, and then just like the holes inside the case. Okay, OD on the seal 1380, and then the depth is 260 thereabouts. I'd like to put it in probably a few thousand, well, 5 or 10 thousandths below surface level, just in case there's anything on the old element that wants to rub up against the outer lip of the seal. So 1380 and depth of 260. Just a quick set. The boring bar tool I don't use very often, so I just use a quick set with the Edge Technology little bubble gauge, which I proved it actually works. Holy smoke, Stan's using a real chuck key. Okay, just giving you a snapshot of the setup there. That's the Touch DRO talking to the lathe this time. Got everything working. So we will dial that in and bring you right back. Okay, so from this one I've added a point. So that's 2/80 thousandths deep and zeroed out, touching off. So that should be my starting point. And when this clocks down to 0, I'll know I'm at depth. So we're going to back it off. Okay, so when the Y is at 0, that means I'm at full depth, so I'll be able to control that. I'm not going very far, so I'm probably going to hand feed it. And we have a starting point. We have 872 to 1380. We've got a ways to go. So, backing it out here. Let's start off. We are A1, we are at 240 RPMs, probably a little slow. We'll see how it cuts because we're going in fast iron. Here we go. Feeding out. Let's go 35 thousandths, see how it likes it. And we're on diameter setting. So this is 35 thousandths off the diameter. Cutting nicely. Coming up on it, don't overshoot it. Okay, we're full depth, we're zeroed out, we've taken a 36 thousandths cut. So now we back up. A little springiness there. And we will go right back along, bring you back. I'm going to go this fast forward it so you can see it, but we'll bring you back. I am taking a little bit of a long shot here just so you can see the inside of her where I gave it the embedded stop. Now one thing you might say, well that's pretty thin. Yeah, but this thing is this much of solid bearing all the way down. So there's not going to be really any load here on the edge at all. So that seal is just going to sit there and float. So I don't think I have any worries about cracking on that edge. we should be good. That was absolutely the smallest seal McMaster offered in that diameter, so I tried to control for it, but that's the best I could get. Okay, all done. Finished up. Just a smidge. I want to do a, I'm not pushing it all the way in, obviously, because I don't want to damage it, because I've got to do that radius thing. And then this one, when I put it in, the gear is going to be coming through, so this will be the last seal that I install. So it's going to be coming in from the outside, but the gear comes in from the inside. So we'll, actually no, it's the other way around. The gear actually bolts on the inside, so I could put it in, but we'll wait for that one. But we're probably just a thousandth or two over, but it is a nice snug fit, and I'm going to hit it with some Loctite around the edge just to retain it. And let's flip it around and do the other side. Maybe 5 more. And there you have it. That's got just about the right kind of a press fit. I think I like this end better than the one I did on the other end. So that should be done. So 2 seals to depth in this housing. We should be in good shape. There we go. Okay, we'll bring you back. Okay, we transitioned everything over to the mill. What's nice about it, for those of you that have seen before, you're all good on that one, but for those of you that haven't, I'm using Touch DRO. I have 2 separate Touch DROs, one on my mill and one on my lathe. So same tablet, same everything. I just transitioned the connection very easily via Bluetooth, and now I'm using the same display for the mill. We're going to get involved with that. Notice how it's doubled up to, actually not double, but 1.5 times now. It has 3 axes as opposed to the 2 you were looking at a while ago. So let me get this centered, and then we'll go from there. So what I'm going to do is I'm going to take up and get the center, and then I'm going to go ahead and set up a radius difference, which is going to pick up the bolt holes that we want to set. And then we're going to punch those out, and then we'll be in good shape. Okay, same exercise. We've got the Y done. We're going to lock the Y. It's at 0. We should be centered, hopefully. And then we're going to run the X. Same exercise as before. Because I'm using the outer edge of this one, I'm really not having to offset the center line. So it's measuring the span on either side of it, so it should have me centered. I may be wrong. I've been wrong before. 0 out. And it kicked. All right, X and 0. All right, take the X across the other side. Okay, 1.178. Hey, what was the other one? 1.177? I think we're pretty good, depending on where I was shifted left or right. All right, again, I'm going to take this. I'm going to hit that. I'm going to hit the half button and 589. So I'm going to run back out to 0. And that should put me on it. Okay, hands hold, but I think you can get an idea of the perspective there. Again, the edge finder isn't centered, but you get the general idea that it just centered everything up pretty nicely. Okay, here, create a circle, 1.35, number 4, offset 60 degrees. Create circle. Sets the 4 points for us. Switch over to the preview workspace, and there's our settings. Again, I'll get out of the thing right here, 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 here. That should help us avoid everything that's a problem. So, let's get to drilling. Okay, going with a 21/64 after I set the pilot on that one. Just going to cast iron. You've all seen people drill before, but yeah, we'll go the overhand reach. It's cast iron, no problem at all. I was going to countersink them, but it's only 1/2 inch thick. So by the time I go 300 thousandths for the head of the bolt, there's not much left, or 350 thousandths. So I think we'll just use regular bolts. Last one. Okay, 1, 2, 3, 4. Yep, need a vise handle too. So we have here, 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 and here. That's our new 4 holes. Clear of the other ones. And as we mentioned earlier, we counterbored it for the seals already. So that's been a full night of fun and adventure. I'm gonna see if I can finish it up. Okay, got it bolted back in place. This top side where the ram is, so there's gonna be the oiling hole. And at the same time, we've got it set up on the old bolts. So you can see the black outlines from the ones that are mine. I'm gonna transfer punch those in, and away we go. I think some of you already have these, you've made them shop made or whatever, but these are from Gator Tools. They are drill guides. I like them because they're not huge. They have a V block on the bottom of them. But as far as keeping something relatively straight, right here, it's small enough to lay it across and get it square. So at least I started straight. Okay, so if you haven't got any of those, make them. I mean, there's nothing to make it. You just got to sit there with a drill bit and go crazy for a while. But they work really nice. That's the drill bit selection. And then they likewise have the tap version, which are already sized to fit the taps. If you can see that. There we go. So it keeps you helps a great deal, especially if you're not on a mill with a tap. I'm not lugging this thing over to the mill just for this. So I'm going to use these to do a 5/16/18 tap and go from there. But first I'm going to need to make these holes. Okay, drilled and tapped, all put in, seals are cut, ready to go. So these need to be plugged, these extra holes here, and then just for giggles, where they used to be inside, probably do a little better than what I've got here, but just for argument's sake, I went ahead and added some hex head socket screws into those old ports. So they're sealed up, they're Loctited in, but I may do something a little bit better than that. But either way, it's going to add structure back to it where there's a void. So at least it'll hold. I think I'm going to wrap it up for tonight. My wife's plane was delayed in New York. They finally canceled it. So now she had to turn back and go to my son's house. So I just put the evening to use. So thanks for watching.